See her in there. I'll answer that. The answer is no.
When's total or annular?
9:30.
Alona, no.
9:30.
Hello and welcome to Lowell Observatory's live coverage of the annular eclipse. This is such an exciting event and we're pleased to broadcast live from Lowell Observatory. My name is Kevin Schindler and I'm the Public Information Officer and Historian here at Lowell Observatory. And the place is abuzz. I know all across America, there's so many people watching this event. Right behind me, I'm inside of a classroom of our Giovale Open Deck Observatory at Lowell Observatory, just about 50 feet from where Clyde Tombaugh discovered Pluto. And so there's a lot of magic and mystery where I'm sitting. And just outside the windows behind me are hundreds of people right outside. We have probably a couple thousand people here. I'm excited about the eclipse. We've got all sorts of telescopes set up and programs, and we're looking at Venus and the sun and all sorts of things. The sun through a lot of different filters. So for the next hour, we're going to be talking to you about the eclipse. And when I say we, I want to introduce Dr. Sean Sellers. Sean is gracious enough to join us here. He's a support astronomer at Sunspot Solar Observatory Consortium. Welcome, Sean.
Good morning, Kevin. How are you all doing today?
Hey, we're pretty excited. This is the kind of event that there's just a buzz. It's not just us astronomy people who get a kick out of this, but it's everybody of all walks of life, because it's something you don't need much to be able to experience it.
Except some eclipse glasses or welding goggles. Just want to make sure that we're all on the same page for that.
And we're going to talk about that, about how best to view the eclipse, because there are a lot of different ways of viewing it, whether it's with glasses or using what are called pinhole projections, all sorts of things. So Sean, tell us a little bit about where you are and why you're interested in the sun.
Well, where I am right now is actually the beautiful and sunny Sunspot Solar Observatory. I'm actually inside our solar telescope right now, on the observing room floor. The bright light over there is reflected sunlight that I'm trying to avoid for my camera's sake. And the reason that I love astronomy, the reason that I'm here, is because it is genuinely one of the most interesting things that I could possibly imagine to do with my life. I am incredibly privileged to be able to spend my days taking data and observing the sun.
Well, thanks, Sean, and welcome to this broadcast. We're really pleased to have you here. And we're going to be showing views throughout the next hour. And actually, the program will continue after we're done talking. But we've got views. You see a lot of people at what looks like some sort of white building. That's our historic 24-inch Clark refracting telescope dome. And that's one site that we have open today. So we have a camera that'll just be there all morning. But we also have live feeds from Sunspot, as well as Placitas Community Library. Steve Snyder, an amateur astronomer and president of the Albuquerque Astronomical Society, has set up a telescope. And we here at Lowell Observatory and you at Sunspot aren't quite in the path of annularity. We'll see here in Flagstaff, the sun will be about 85% eclipsed. But Steve is in a place where it's going to be completely in annularity. And so we're going to keep that feed going the whole time, and you'll be able to see that ring of fire. And every time we talk about this, I think Johnny Cash keeps going through my head. And the Ring of Fire song. And I think there's a lot of songs that work out nicely here. So for the next hour, we're going to chat about the sun. We're going to take some great views. Sean, I hope you get a chance to look outside. It's to my back, so I'm going to maybe jump up a couple times and take a look at my glasses. But let's start with that of, first of all, what is an annular solar eclipse, and how does that differ from a total solar eclipse or a partial eclipse? There's a lot of terms. What's the difference for all those?
Sure. So a solar eclipse, most generally, is just when the shadow of the moon falls upon the surface of the Earth, or more specifically, when the moon moves in front of the sun from our point of view. There are three types, as you mentioned, three main types of solar eclipse: annular, total, and partial. Partial is when the disk of the moon does not fully cover the disk of the sun. You'll see it look like that great Pac-Man view that you can see on the live stream right now. We are technically currently in a partial solar eclipse until we reach our maximum. A total solar eclipse is when the moon has about the same or slightly larger of a diameter than the sun, and the entire disk of the sun is blocked out. And you've probably seen pictures of this at some point. You are able to see the solar corona, the atmosphere of the sun, about 1,000,000 degrees Kelvin, radiating outwards from that blocked disk. Today's event is what's called an annular solar eclipse. It's when the moon moves fully in front of the sun, but is just a little bit too far from Earth to fully block the entire disk, creating the, yes, Johnny Cash ring of fire effect around it, as you are still able to see a small region of the surface of the sun in a big circular shape around the edges of the moon. The difference between them is basically whether or not you need eclipse glasses to view them. So for annular eclipses, you most certainly do.
And we'll talk about viewing a little bit more a little bit later. These annular eclipses, you mentioned about it happens when when the moon blocks the sun. So why doesn't that happen every month? Because of course, we know how the moon orbits the sun or orbits the Earth, and Earth orbits the sun. So why doesn't that happen as frequently as we think it should?
Well, it would be nice to be able to think of orbits in terms of just flat circles inside of flat circles, and that was how we thought of them for a very long time. But in space, there is the fun added third dimension. So the moon orbits the Earth in approximately a circle. It's actually a little bit of an oval. Technically, you would call it an ellipse. But it also passes just above and below the plane of the Earth's orbit from the sun. So you can think of it, if you draw a line from the Earth to the sun, at certain times the moon is above that line, and at certain times the moon is below that line. You only get a solar eclipse, partial, total, or annular, when the moon is actively crossing that line.
And I think there's something else that's really fascinating. It's the time that we live. The fact that we can have solar eclipses because the apparent size of the moon and the sun, we know that the sun is much larger. You could fit something like 1.3 million Earths inside of the sun, and the moon is a lot smaller than that. The moon is about the diameter of the United States, roughly. So even though the sun's diameter appears to be 400 times bigger than where we are, it's also 400 times further away, so that the moon and the sun appear about the same size in the sky. But as you said, that the orbits, nothing is perfect. So sometimes the moon is a little bit closer to us, sometimes a little bit further away. And when it's further away, the moon isn't quite big enough to cover all the sun. That's when you get that ring of fire.
Right. And like you mentioned, this is a very, very privileged point in time because we are able to see total solar eclipses and annular solar eclipses. A couple 100 million years ago, there were no such thing as annular solar eclipses. The moon was closer to Earth at that time. In another couple 100 million years, the moon will have drifted further away and there will be no total solar eclipses. We are very lucky that we get to live in a time where we can see all of them.
Right, it is pretty fortunate. So how often do these happen?
So solar eclipses in general occur multiple times a year. The average is about 2. The maximum you can possibly have is 5 solar eclipses within the span of a year. That's very, very rare. The last time that happened was in 1935. So, some of you on the stream may remember that. The next time that 5 in a year will happen is 2206, I believe. So a little bit in the future. But on average, about twice in a year. Generally speaking, you can get a total solar eclipse, an annular solar eclipse, or a partial solar eclipse every 2 years in a place where people could theoretically observe it.
Yeah. So the last annular solar eclipse in North America was in 2012. And,
correct, May 20th.
Yep. And when's the next one?
The next annular solar eclipse is going to be in 2039. I believe it's going to be June or July, but I'm not 100% sure on the date. I haven't put it on my calendar just yet.
Yeah, right. Mark that off. And it is, again, it's just like we live in a time when we can actually see solar eclipses, total solar eclipses and annular. But this is a really golden time right now because today we have this annular eclipse that we can see across North America. You can't see the annularity, but you'll see some partial phase of it. And there's just that narrow strip, the center that you can see annularity. But then we won't see something like that across North America for a decade. And then next year's total solar eclipse that's going to go across North America, that's the last one we'll see in North America for a couple decades. And so we're really pretty fortunate right now. It's really golden time to do solar observing.
Yeah, it's genuinely fantastic. And if you can make it to the totality of that total solar eclipse next April. I would highly recommend it. There was one in 2017 that I was fortunate to be able to see, and it was one of the, I would say, defining events in my life.
It really is. I think of it as, seeing a partial solar eclipse is fascinating and inspirational, and seeing a total solar eclipse is life altering, because you don't just see it, you feel it, you experience it. It's the cooling temperature, the nightlife that comes out depending on where you are, the sunset in every direction, the weird eerie glow of the light. It's just a special experience. And so this feels kind of like a nice warm up to that.
Yeah, certainly. And I mean, an annular solar eclipse is not exactly something to scoff at here. I expect today to be fantastic, really.
Yes, yep. So let's talk about how to view these things, because we have I think a couple thousand people here at Lowell Observatory, people across the country. This is going across North, Central, and South America. So a lot of people are seeing it in our area of the world. And so, we know about not looking at the sun, but let's talk about that a little bit more, the different ways that you can look at a solar eclipse. And I have a couple things I'll show too while you're talking. So let's just talk about that some.
So looking at the sun is obviously not something that you would typically want to do. I think probably everybody has a point in their childhood where they were told not to do that and have kept that ever since. There is equipment that you can use of varying expense to try and observe the sun without damaging your vision. Probably the most common way would be with a pair of eclipse glasses. These just look like little cardboard, almost like the 3D glasses you used to get at the movies, but with a filter inside the lenses that cuts out 99.999% of all of the light and just leaves a little bit left that is safe to view through. You can tell if you have a genuine pair of eclipse glasses, more or less. If you put them on and you cannot see anything at all, those are eclipse glasses. You should only be able to see the sun with them. Your surroundings will be completely dark. That is one of the more common ways. If you have,
I was going to show I have a pair of these, and everybody here at Lowell Observatory behind me has a pair of these. We're giving these out. I also like kind of a more heavy-duty style. They look like regular sunglasses, but they're not. Like you said, you can't see anything unless you're looking right at the sun. So there are several different types of those that you can use. Also, before you go on, I've got these binoculars, these Eclipse binoculars that are pretty cool that you can, you hold them up and look out of them. So those kind of devices are pretty cool. And there's a lot of variety of those.
Yes, yeah, and you can buy just the film that goes inside those. I believe it's called a Bader film with 2 A's that you can use to make binoculars safe, use to make telescopes safe, as long as they're not too large. And that's something that you can do if you're interested in trying to pursue that further. And I did see somebody in the chat here on YouTube mention that, yes, welding glasses do work reasonably well. They have to be a fairly thick set of welding glasses, but if you are a welder, you can go grab your equipment and take a look at the sun.
Right. So how else can you look at the sun?
Well, the easiest way would be to just get a pinhole projection. So any small enough hole in a surface will act basically like a camera. So if you have like a piece of cardboard that you can kind of make reasonably dark behind it, and you poke a very, very narrow hole in it and hold it above some sort of projecting surface, a piece of paper or something, you will be able to see the projection of the sun through that pinhole. I've seen people do this even with things like household objects like a colander, for example. If you have a piece of cardboard or anything that you can poke a hole through, you can go outside right now and project the sun onto the ground.
And that's what's great about this partial eclipse, because it's going to be going on for a couple hours. And so there's plenty of time. Something that my wife has done is, for the 2017 eclipse, was make designs like the outline of a bear or whatever with holes, and then you project it, and you get all these projected eclipses. And the more of a crescent you get, the more cool it looks, I think. I have a personal memory of 2012. It was a great event here at Lowell Observatory. We had a lot of people up here, and I was living up at Lowell at the time at some of the housing here, and Gretchen came over to take a look through telescopes, and there were so many people, she decided just go back. She didn't want to get in the way of our visitors, looking through the telescopes. So she went back to our house, and our garage door was completely covered with little crescent suns because you're talking about the pinhole viewer. Nature creates pinhole viewers as the sun is passing through like leaves of trees. Um, the sun will come through and you'll get these little images of the sun. This happened in our garage door, and the whole door was covered with these really neat crescents. And so there's a lot of different ways you can see it. And the projected method is you're not looking directly at the sun, but it's safe and it's easy to see. And I think, the one thing like with the projection is, like I have a little card here from the 2017 eclipse that has a hole going through it. You just have to move it a little bit back or forth toward what you're using as a screen, like the piece of paper or sidewalk, until it comes in focus. And like I said, the more crescent the sun is, the cooler it's going to be.
Right. Yeah. And again, if you can project that onto something that'll keep the image, you will be able to see that as the eclipse progresses. Those crescents get, well, smaller and smaller.
And so of course, then you can also look at the sun through telescopes. And there are a couple different kinds of filters you can use with those. Let's talk about those a little bit.
Sure. So there are ways that you can take a look through your telescope at the sun. Don't do that just regularly unless you're pretty sure of what you're doing. But the most common way is to use what's called a white light filter, which is basically the same thing as those eclipse glasses. It just cuts off most of the light, just intensity wise, leaves you with just a very, very small amount of sunlight left. You can buy these that screw on to the fronts of like amateur telescopes. That would make it safe for viewing. Our outreach telescopes, we have a handful of those just for day-to-day use as well. That would be probably one of the more common ways. There's also, you can buy a specialized kind of telescope, an H-alpha telescope, which I believe you guys have a few of set up at your facility. An H-alpha solar telescope works in a different way than a white light solar filter. So I said white light, it just cuts down the intensity. It's basically like you just take a piece of really, really dark or like smoked glass or something basically and cut off most of the light coming through. But an H-alpha telescope actually works by selecting colors of light. So white light from the sun is actually a rainbow, right? We can see this anytime it rains or, through certain windows. A prism will do the same thing if you're, a Pink Floyd fan. White light is a rainbow, and those different colors of the rainbow have different properties depending on, basically what's causing them. So in the sun spectrum, there are a few very, very specific bands of light that we consider to be special. One of them is H-alpha or hydrogen alpha. It is a reddish color of light, 656 nanometers, for those of you who keep track of that sort of thing. But H-alpha is a spectral line which is caused by the emission of hydrogen actually within the sun's atmosphere. So H-alpha telescopes will actually take the light from the sun and cut off all of the blue light, all of the very red light, all of the green light, and leave you only a very, very small slice of reddish light left to view from. And you'll actually see different structures when viewing through an H-alpha telescope versus when viewing through a white light filter. A white light filter will show you the surface of the sun. You'll get to see things like sunspots. The edge of the disk will be in very, very clear relief. But for an H-alpha telescope, you'll start to see all sorts of very strange and filamentary looking structures on the sun. You'll get to see prominences coming off the limb. You'll get to see bright spots if there's a flare. You'll get to see kind of like dark lines and loops on the solar disk itself. Just a very, very different and very interesting way of looking at the sun.
And so the first one you mentioned, using the white light, that's what we have from our Placitas community library view right now. Thanks again to Steve Snyder for supplying that. And it's just so crisp and clear. If you took a first glance at that, you might think, oh, there's a crescent moon. But
right.
We know, of course, it's not. And today there's not much solar activity because using seeing the white light, you can really see sunspots well if they're there. And I saw earlier in the feed, I saw one sunspot, and I think I don't see it right now. Maybe you can, but I think it's probably in a part that's blocked.
Yeah, it looks like it's just gone behind the moon for us.
Yeah. Okay. So what are that kind of stuff you can see? Like when it's coming out of eclipse later, you'll be able to see that again. What is a sunspot?
So when you're looking at the sun safely, as we mentioned, you'll be able to see what are just called sunspots. They just look like little dark spots on the surface of the sun. There is at least one group right now on the solar disk that is large enough to be seen with the naked eye through eclipse glasses. Sunspots, these little kind of compact dark spots, are regions of intense magnetic field strength. The sun has a magnetic field, like the Earth does, but that's about where the similarities end, is that it has a magnetic field. The sun's magnetic field is very chaotic. It can gather into intense concentrations or spread out over large areas. Sunspots are those really, really concentrated areas. They have a strength on the order of, in scientific terms, about 1,000 Gauss or more. That is, in real terms, about 10 fridge magnets, which doesn't sound like a lot, but sunspots are also, on the smaller side, the size of the Earth. And that magnetic field, in that kind of concentration over that large of an area, it creates these dark spots because those spots are actually forced to be a little bit cooler. That magnetic field acts like a thumb on top of the rising gas from the interior of the sun. It keeps that new gas from rising up. And since the gas being dredged up from the interior of the sun is a lot hotter, the gas that's kind of forced to stay there at the surface, and there's no new gas that can rise, those sunspot areas, those are a lot cooler, a couple thousand degrees cooler.
And, just looking at the time here, we've got about 10 minutes or so until we reach annularity. And this is going to be really cool to be watching our feed from Placitas Community Library, because they're in that path of annularity, and we're going to get that ring of fire. So just 9 or 10 minutes or so, that should be happening. So let's talk a little bit about what's going to happen over the next 10 minutes. And you were talking about the moon passing in front of the sun. What's that going to look like as we go over the next couple of minutes?
So over the next couple of minutes, as we start to watch the shadow of the moon creep across the entirety of the sun, you'll be able to kind of start to see, well, it'll get a lot dimmer if you're in the path of annularity, for one, outside. But for another, you'll start to actually see the other side of the moon as it goes across the sun, until you end up with a really bright, perfect ring of sunlight surrounding that kind of dark shadow. I'm not sure how well it's going to show up on the Placitas image, but if you're in the path of annularity, or if you look really closely, you'll even be able to see the mountains of the moon in relief against the disk of the sun, which is a fantastic sight as well. Lunar topography. Makes you feel like an old Apollo astronaut.
Yes,
But over the next 10 minutes or so, you'll start to see that image of the moon fully come across the disk of the sun and then proceed out the other side of it bit by bit. Annularity in Placitas, I believe, lasts about 4 minutes or so, so we should have plenty of time to get a good view of it.
Yes. And as you're talking, we're 7 minutes away or so, but here in Flagstaff, about 85% of the sun's going to be eclipsed. And I can certainly tell a difference, because I have my back to the windows, and just the light in front of me that's coming through the windows, it's gotten a lot dimmer. It's certainly not going to get dark, but it's noticeably darker now. And it's interesting because I can hear outside. Before there was a buzz, and now it feels more like a standing there in awe, because if you're using your solar glasses, you can see the eclipsed sun. But if you're just standing there, you can't tell the difference much in sunlight until it gets to a certain point, and then suddenly, wait a minute, it's getting darker.
Once you hit about 75%, you really start to notice.
Yeah, and that's what we're starting to move toward, that range now, and I can hear and sense the people outside. It's just more of a stand back in awe, and I think that's maybe one of the reasons you like astronomy so much. You can answer this, but so much of the awe and wonder, you just stand outside. For certain things like looking at the sun, you need special equipment, but you can still experience it, even if you're not looking at the sun. You can be outside and know that something is really weird happening, and it's that awe and wonder we get of the night sky and the day sky. And we get so tied up in the happenings of our world and the busyness and everything, but it's nice to take a moment once in a while and just step back and enjoy the natural world around us. And it's stunning. And so I don't want to speak for you, but it seems like most people that are scientists have that sort of appreciation.
it is genuinely awesome in the older sense of the word, as an inspiring awe in every time I see it. I'm fortunate to be able to go to a lot of these observatories, both nighttime and daytime. I never get tired of it. Um, it really is a fantastic way of keeping some perspective on us here on Earth. I mean, the
Right.
sun weighs 200 octillion grams, I want to say, a 2 followed by 33 zeros,
Yeah.
grams of matter, which is just such an immense quantity. These things don't fit in the human mind. There's 93 million miles between us and the sun, and it's our nearest star. And today we get to watch it be blocked out by the moon. And in fact, I can kind of show you maybe a little bit here, but it's gotten a lot dimmer inside our observing room here at Sunspot. I don't know how far my camera cable will stretch, but you can see on those monitors back there, we're getting pretty close to our maximum here in Sunspot.
Yeah. So tell us a little bit more about the facilities there at Sunspot. It's a really unique setup you have there, and the tower it's very distinct. If people see a picture of it, you know what you're looking at.
Yeah, so Sunspot Solar Observatory, they built one of these and they will never build another thing quite like it ever again. The site's been here since 1946. It was founded by the Air Force, actually, in the aftermath of the Second World War, because in the early stages of World War II, British and American radio men started noticing that solar flares were actually affecting the quality of their transmissions. And after the Second World War, there was a need to kind of study the sun in high detail and try and understand some of these events. And so Sunspot was born. Over the years, it's evolved quite a lot, but the main feature, as you mentioned, is the Dunn Solar Telescope, where I am right now, which was built in 1966 to 1969. It is a 136-foot tall tower over a 230-foot deep pit. The telescope itself is about 300 feet long, top to bottom, with an entrance aperture that's only 76 centimeters across. Well, doesn't fit in the frame quite, but, yay big. It's still one of the best 5 solar telescopes in the world. It's still an active scientific research facility. We use this thing to capture some of the best quality data of the sun available in the entire world. The entire thing is basically vacuum sealed on the interior. Our telescope is 300 feet long, and all 300 feet of it are in a vacuum, top to bottom. And the whole thing actually is built to rotate to track the sun. It is a genuinely incredible facility. Been around for 50 years. They will never build anything quite like it again, because it turns out making a 300-foot long section of telescope rotate freely is a non-trivial task. The gentleman who designed it, Richard B. Dunn, was some kind of genius, I can tell you that.
Well, we certainly appreciate you joining the feed here and tag teaming on this program. And this broadcast is typical of so many things we do here at Lowell Observatory. Our goal is to communicate science to I say the world, but the universe, because we're an observatory. And so we have incredible research astronomers. We've been doing research here since 1894, 18 years before Arizona was a state. Lowell Observatory was established. And we've got astronomers today that study anything from the sun and sun-like stars to asteroids and comets and the outer solar system like Pluto, water and ices in the solar system, massive stars, galaxies. One of our scientists studies cannibal galaxies. And so there's just a wide range of things. But one of our scientists, Dr. Giovale, he has a telescope he runs called, the acronym, there's an acronym for everything, but it's called LOST, the Lowell Observatory Solar Telescope. And so he's studying the sun with that and using that as comparisons to stars around other, or stars outside of our sun, beyond that. And that helps in things like looking for planets like Earth and so on. So what kind of research do you guys do there with the sun, and talk about that legacy a little bit?
So like I said, this is still an active scientific facility. We actually study small regions of the sun in incredibly high detail. Some of the best detail that you can get of the surface of the sun comes from our facility. We study all kinds of events here, depending on the time of decade, because there are cycles to these things. We can be studying solar flares, which are colossal explosions on the surface of the sun, Medium-sized solar flares will get you an energy output of about 100 million hydrogen bombs all put together over the course of maybe 10 or 20 minutes. A big part of our research time is dedicated to trying to study those events, understand how they occur, why they occur, and the sort of ripples that they leave in the sun's atmosphere in their wake. That's one of the things that we do. We also tend to study the energy transfer from the sun's surface up into its atmosphere, the corona, which I mentioned earlier, you can actually see during a total solar eclipse like we will have next April. The solar corona is a really enigmatic layer of the sun's atmosphere. We don't understand a lot of the dynamics happening there very well at all. One of the great unsolved or only partially solved questions of physics right now is, why is the corona of the sun the way it is? And that's one of those questions that we're trying to kind of disentangle here at Sunspot. We also do a little bit of work on the nighttime side of things. We've got a couple of guest instruments here at the telescope that actually try to study the winds of Jupiter, which is not what the telescope was designed for, but it performs quite admirably in those situations.
Well, that's great. And again, connecting with you, because you guys do astronomy, we do research. That's a central focus for what we do. And there's so many applications to studying the sun, because there are other stars. We know the sun the best, but there are hundreds of billions, trillions of stars out there. And the more we know about the sun, the more we can learn about some of those other stars. And, it also goes to that question of, looking for life elsewhere. We know of life on one planet in the solar system. And so the more we learn about the sun and its family of planets, the more we can learn about the potential of other systems out there like that. Where life could exist. So there's a lot of different applications of studying the sun. Now we're right at about, approaching the darkest moment, and it's just getting just a little bit eerie, but pretty cool looking. And as we reach this point, like I said, we do these events at Lowell Observatory, and it's really special for us and important for us to partner with different organizations, and certainly partnering with you, Sean, and Sunspot Solar Observatory is really important for us. And we also have a lot of partners that we'd like to thank. Grand Canyon National Park and Grand Canyon Conservancy is who's sharing this feed. The City of Flagstaff and Discover Flagstaff, who helps us promote so many of our activities. Planet Science, which is a retail store in downtown Flagstaff where you can get the coolest astronomy memorabilia and gifts. They're a branch of Meteor Crater, friends of ours, the best preserved impact crater in the world. And so Planet Science is on site here with doing a booth for family. Heather Craig and Maddie Mooney are our behind the scenes team, who are calmly but furiously making it all work. And as anything with this, there's always glitches, and they're just working through it seamlessly. So we appreciate that. And of course you, Sean, and then Steve Snyder, who is supplying this feed from Placitas, and it's just pretty stunning to see. And this is the wonder of technology, that it's great to go outside and see it, but it's also nice to see what it looks like elsewhere. And so I'm just looking on my phone at the feed, and it's getting a really nice crescent shape.
That's fantastic.
Yeah, it's just you kind of look at it and it's just stunning for a little bit. You think about what the ancients thought about this before we understood about the sun and the moon, and there were a lot of concerns in early cultures. The sun is disappearing. And what do you make of that? And there are stories through history where, as we started learning about the sun and the moon and how and Earth, and how that they dance together and sometimes get in each other's way, how we started to learn about this. There's the story about Christopher Columbus, who was stranded, and the indigenous people and his team, they were having some troubles, and so he supposedly said he knew there was an eclipse coming, and supposedly said, if we don't resolve our troubles, we're going to take the sun away. And then it went into eclipse, and that got their attention, and they resolved their problems. And so there's a long, interesting history about both solar and lunar eclipses in our culture. And I think something that's worth mentioning also is we live here in northern Arizona as well as you in New Mexico, where we have a lot of indigenous people, and there are some groups that they stay inside all day and don't look at the sun because it's part of their culture, and we certainly respect and honor that. We all celebrate nature in different ways, and and it's very fascinating to learn about those different ways.
Yeah, we've actually got up in the Sacramento Mountains where the telescope is located for us. There are a handful of ancient solar observatories, similar to things like Stonehenge, designed to kind of track the movements of the sun and predict things like, well, these solar eclipses, which I'm noticing is fully annular now in the Placidus view here. That is fantastic.
Yeah, it's stunning. That's just so fascinating to see, and we have to wait a decade to see this again, at least in this country. And so it's a great opportunity to see this. So I think we'll just take a couple moments and just enjoy the views we're getting, because I think it's good just to sit back and just be for a couple minutes. As Yogi Berra said, you can observe a lot just by watching. Gosh, I feel like we just took a moment of silence in reverence, because nature is an amazing thing, and to be able to experience this, and Sean, is certainly a pleasure to experience this with you as somebody who studies the sun. And this is, for all of us, this is a unique opportunity for us here at Lowell Observatory, our scientists who study the sun and other stars and other things in the solar system. For you, this is what you do, and to be able to see an event like this, what are you feeling right now with all this?
Awe. I mean, is the short answer. I am just absolutely thrilled to be here. I've been to one other solar eclipse, the 2017 up in Wyoming, and there is a couple of moments in each of them where the scientist part of my brain turns off for just a couple minutes, and you're just kind of forced to exist there and really see what is going on around you. It shuts down the higher order reasoning of the brain, I guess you could say, and leaves you only with sort of this genuine awe of the world around you. I mean, I've got images of it around me here inside the telescope here. And I feel like a kid in a candy store, honestly.
Well, so you stop. Well, I say in some way you stop being a scientist, but that's not the case, because scientists are people too.
Sure.
It turns out,
sometimes I would disagree with you, but
yeah,
sure.
Right. but it's an emotional experience. It's more than just what you're seeing. It's feeling it and what's happening, and it's just stunning to see this view from Placidus, and just how that ring of fire is. It just really is stunning.
Yeah. And again, if you've ever seen even a picture of a total solar eclipse, you can kind of understand the awe with which these events were held throughout history, across cultures, across nations, across people, across years. A solar eclipse is truly a unique and awesome experience.
So as we're looking at this ring of fire, let's talk about how this compares to next year, and as we get to this moment next year, we'll get to a moment of totality. What's the difference? What will it look like at this time next year?
Yeah. So real quick though, I do just want to mention, if you take a look at that Placidus view right now, along the bottom edge of that image, you can see the mountains of the moon on the lower edge of the moon as it's proceeding off the disk of the sun. I just want to make sure everybody is aware that that is what they are seeing. Lunar topography, more or less. There's not a lot of mountains on the moon, but there are a handful, and you can see them during these events. But to answer your question, what's the difference between this? What are we going to see next year? the total solar eclipse, it is truly a different and, like you said earlier, life-altering sort of experience. It's not just seeing the corona of the sun, these outer layers of kind of wispy, thin material. It is the full experience of standing there, as you said, as sun sets across the entire horizon at once, as the birds quit chirping and as the nighttime insects start to kind of kick up. As the air gets colder, there's like a wind that picks up. All kinds of just this full experience, really. But as for what you will see, as I mentioned a couple times, you will see the solar corona. You will no longer see this ring of fire, although there are parts of the total solar eclipse where you can see little bits of the lower sun's atmosphere, this dark red kind of structure. But for the most part, what you will be seeing is the outer layers of the sun's atmosphere, which are invisible except during solar eclipses. The low corona is really only visible during an eclipse. That is the only time that we can see it. That is the only time scientists can study it. There are plenty of people that I know who are involved in trying to get data of these, this structure that is so mysterious to us. But when you see it, you will see these kind of like long strands leading radially outwards from the sun, and sometimes gathered into bundles, sometimes kind of like open fan-shaped structures. It will be larger than the disk of the sun appears to us, about 2 or 3 times as large, maybe up to 4, depending on how good your eyes are and how acclimated to the dark you are. The solar corona is 1/1,000,000th the brightness of the sun, so this is the only time that you will be able to see it with the naked eye. It will be a fantastic experience. So the eclipse path comes in from the west coast of Mexico, travels up through Texas, across Big Bend, through like the middle states in there, clips through Ohio on its way up through Pennsylvania and New York and outwards towards Canada. So if you're living somewhere inside that path, keep an eye out and be aware of the increased number of tourists around your home. And if you live outside that path, you might want to be one of those tourists outside those people's homes.
It's going to be exciting time. You know, this ring of fire is mesmerizing, you know, invigorating, exciting, and the total solar eclipse is even more so. And so, you know, if you like this, make sure to make plans to see the total solar eclipse. Now,
It is genuinely unearthly.
Yep. Let's go back and look at the images we have here. We've got the one back from Sunspot, and then the one from Placitas. And what are we seeing? You talked about a little bit about the moon, but look at Placitas, how close it's getting. Just right now, it's happening.
Yeah, so we've just moved out of annularity on there, and we can kind of see like the limb of the sun. The sun is not actually a uniform disk across its entire face, but there are kind of like dimmings around the edges where the plasma, you can actually see more of it as the sun kind of curves away from us here. So what we are seeing now is kind of like the cooler limb of the sun. It's kind of like darker, redder material. It actually physically appears to be redder. Around the edges of the sun, the part that's either rotating, I think at this point, away from us is the limb that's currently visible on these images here.
I've just taken another look at my phone here where I've got the feed. Isn't technology great? You can just—
It is fantastic.
You know, like we're talking on here, I'm watching the feed, which is delayed, but being able to see it, because I'm not getting up and looking through the glasses, I'll do that again a little bit later. But it's just such an invigorating experience. We keep saying that, but it's where the you know, the side of our brain that does science and the side of our brain that does awe and wonder, it's all merged together. And it's something that everybody can share. And we are now with all these people around here. I mentioned that we have, I don't know, a couple thousand people maybe. We had a big staff outside helping with parking, and because there's only so many places you can put people up here. And it's just been a great experience from what I've seen through the window, just the buzz, the excitement of seeing something like this. And, you know, you see it with other people in this experience, like it's like going to your favorite team in the Super Bowl or something. And there's just, when you're surrounded by people that are there for the same reason, it adds to that excitement. It makes it a real human experience. And so I think it's one of those moments that, you know, so often in the news we see things where, the front of the newspaper is more often, it seems like, bad news than good news. This is something that you have a gathering of people for good reason, and it's a lot of fun. And, it's great for the whole family. It's what a bonding experience, whether
Yeah.
you're a grandparent or a grandchild or somewhere in between. It's something that everybody can appreciate. And even if you don't understand all the science behind it, it's still something that is so visceral that everybody can appreciate. And I'm hoping young viewers like Addison and others that I'm familiar with can look at that and just say, my gosh, nature is really an amazing thing. And it's really great to get out and just experience the universe around us.
I mean, I might be a little bit biased, but I think that everybody should at some point stare at the sun safely.
Safely, yep. Yeah, that's the qualifier. You always put in safely. But as we've said today, as you said earlier, there's so many ways you can observe it. So let's review that again for some folks who have joined us later. The importance of safely viewing the sun in different ways that we can do that.
Yeah. If you look at the sun with your normal human eyes, even if it's during an eclipse, you will start to go blind. It's not an immediate process, but it's pretty quick. You do not want to try it. To observe the sun safely, there are plenty of ways that you can go about doing it. The most obvious is a pair of eclipse glasses, which are a light blocking film. And I believe, Kevin, you have some on hand somewhere. I don't have my
Yes.
pair handy.
I've got them right here.
Perfect.
And
Yeah,
they
they
make you look really
usually,
cool, too.
yeah, usually they look kind of like your 3D glasses that you'd see at an old movie theater, except when you put them on and look through them, you will see nothing unless you are staring directly at the sun. They cut off 99.99+% of light. So you will not see any of your surroundings. All you will see is sun. And that was one pretty easy way to make it safe for yourself. The film that's in it is called Bader film, I believe, Baader. Although I might be wrong about that. You can buy that stuff in bulk to make your small binoculars and small telescopes safe, or you can upgrade to something called a white light filter, which will screw on to most commercial telescopes and will make it safe as well. The other ways that you can view it are if you have welding glasses from your job or hobby, those will make it safe for you to be able to view the sun. There are pinhole projections, any small hole in any kind of like large material that can block out most of the sun's disk. You project the light onto that and through it, you will see an image of the eclipse on the projected light through there. Even a colander will work for that. As Kevin, you alluded to earlier, the leaves on the trees can form this as well. So any kind of pinhole camera will do that for you. And then if you want to get really, really into it, there are specialized telescopes that you can buy. And again, if you have like a small telescope or small binoculars, you can project the image of the sun through that, but you should be very careful attempting it because you cannot look through it while you are projecting. Again, blindness. And you do run the risk of damaging that telescope if it is large enough. Smaller binoculars will work. Big telescopes, you've got to do something to make it safe.
And while you're telling us that, I think one thing that's important, you're stressing the safety. You said that the sunglasses block 99.99% of the light. And it's also important just to add on that the light that does come through is not hazardous.
Correct.
The whole point of those. So it's not like a little bit is getting through. None of the nasty gets through. And
yeah, there's two things that'll hurt you from an eclipse. There is the intensity of the light, which is bright. But the other thing that is a little bit sneakier is the ultraviolet light, which will just damage your eyeball and you will not notice it happening. Ultraviolet light is kind of sneaky like that. And those films that you can buy will cut off the ultraviolet light and make it safe to view.
right. And I'm going to do something. I think I can do this if Heather might say no. I was going to see if I can share my screen for just a second because whoops. Just, maybe I'll delay that. But she just sent me a picture of that she took at the house where I live. It's the side of the house, and it's a bunch of it's the projection of the sun on the side of the house. So the trees are acting as a pinhole viewer. And so let me just share that for a second, maybe. So you kind of get an idea what that looks like. So can you see that?
Oh, that's fantastic. I can see it. I don't know if anybody else can.
Yeah, so all those little crescents, that's the sun. So if you go outside, and this is going to be the case, it's the more increscent it is, the easier it is to see. But anywhere where there's some trees and the sun's passing through, they make those little pinhole viewers. And so go out and look on the sidewalk or the side of the house or whatever, and you can see those really easily.
Depending on where you live, today could be the day that you see 10,000 eclipses.
Yeah, right, exactly. Well, gosh, we only have 10 minutes here. And this is one of those things that, I don't know, it feels like the time flies and it's it'll be coming out of the ring of fire, and, we'll see more and more of the sun. But on the other hand, I feel spoiled because during the total solar eclipse, you don't have much time. Totality is 4 minutes, and you don't want to be doing anything except for experiencing it. There are a lot of people who photograph it, but especially if you're a first-time observer, you should just have your glasses on or your safe viewing device and just experience and not let somebody else get the cool pictures, and you can always use those.
Yeah, I guarantee you somebody will take a better picture than you. I'm no shade on anybody watching, but the one that I would keep an eye on specifically, there is a program called Citizen Kate that was set up for the 2017 eclipse and will be operating for the 2024 eclipse. It's a series of telescopes across the continental United States that all of these different sites will all take images of the eclipse for its entire duration. And since the eclipse proceeds across the United States, you will effectively get a several tens of minutes or a couple hour long view of the eclipse through these telescopes here. So keep an eye on those folks. They should be putting out some pretty interesting stuff here pretty soon.
Yeah, and that's again one of the wonders of the internet. There are so many different ways of finding images and sharing information. This is one of those times when we really are grateful for that sort of thing. So Sean, what's the rest of your day going to look like?
Well, we're going to probably continue through the downside of this eclipse here. We've got plenty of folks on site. I was talking to a lot of folks earlier. We've got, I think, some live music, some food trucks, all kinds of stuff up here at Sunspot. So I'll be spending the rest of the day in the telescope watching as the eclipse kind of winds down, showing people around my very strange and very old telescope that I love quite dearly. And that's about it for me. I'm just really excited to be here. We've got a couple of science cameras that have been taking images of this, so I'm really excited to see how those come out when we finish the eclipse here. So I would also like to plug the Sunspot social media sites. Keep an eye on those for the next couple of weeks, and we should have a movie as well at this event from our site.
Oh, that's excellent. And yeah, thanks for creating that. And we have kind of a similar thing, at the observatory here, that we're open the rest of the day, into tonight. We stay open until 10 o'clock. And so it's sort of interesting that, a lot of these people here now, they'll be coming back later. So it'll go from seeing, eclipse sun to looking at Jupiter and Saturn and some other wonders of the night sky tonight. So it's, day or night, there's something interesting with astronomy. And to me, I'm always fascinated by how much astronomy is in our everyday life. And we take it for granted. But, our day is defined by, sunrise, sunset, our time, a day, a month, a year, that's all astronomy related. It controls, or it's such an important part of our lives, and we take it for granted. And then we get days like this, where we stand back and realize, hey, there's a sun out there, and there's this moon, and they interact, and it's a good time to stop and just appreciate all that.
Astronomy is one of the oldest scientists. For as long as people have been looking up at the sky, they have been doing astronomy.
And you're continuing that tradition. And scientists here at Lowell Observatory and our educators here at Lowell Observatory, I'm again sitting in there's a classroom in our building called the Giovale Open Deck Observatory. And I'm named after a Giovale family who've been such great supporters of not only Lowell Observatory, but so many places across northern Arizona. And this facility is great to be sitting here because I'm in this really quiet room, and I kind of want to be outside because there's so much excitement, but I'm in this quiet room, but right behind me, there just on that patio, there are hundreds of people standing there. And then on the other side of the doors to where I'm sitting to the left is where we have a whole roof, or the whole building rolls back on top of the part that I'm on. And we have 6 telescopes, as well as other ones we've set up for solar viewing today, that we can look at stuff, whether it's day or night, we can look at different things in the night sky. And then we also opened other telescopes, daytime, depending on where a planet like Venus is. And in fact, we're looking at Venus right now. We had some glimpses of people standing in line. There's a big white building. That's our historic 24-inch refracting Clark telescope that's housed inside of that. And I believe they're looking at Venus with that. And, you think during the daytime, you can't do astronomy much, but we're finding out today that you certainly can. It's not the dark skies and looking at faint fuzzy objects, but the sun is the most dominant astronomical object for us. And, we study it every day. And so day or night, astronomy is a big thing, is an important part of our lives, important topic of research for people at Sunspot and Lowell. And it's nice that when all that is together, we can have an event like this to share it with everybody.
Yeah, and you guys mentioned that you were going to be observing Jupiter and Saturn this evening as well. And I really, if you've never seen those objects through a telescope, I highly, highly recommend either going up to Lowell if you're there, or finding an amateur astronomy group in your town, because even just seeing those objects is fantastic. I mean, you look at Jupiter through even a relatively small telescope, you can see the 4 moons, the 4 Galilean moons of Jupiter. It's got more than 4, but you can see those 4 in like this kind of belt of bright lights around the equator of Jupiter. Tonight, you guys should be able to see Jupiter in pretty fantastic detail. I mean, it's at opposition, so it should be nice and bright and beautiful for all of y'all. I really cannot stress enough just how incredible it is to be able to kind of take part in any of these things. And to you, Kevin, I would just like to say thank you for inviting me on your stream here as well. I mean, I went to grad school and now work in part for New Mexico State University, which is where Clyde Tombaugh went after discovering Pluto to found an astronomy department. And, everything in kind of my day-to-day life through all these outreach events, through the telescopes that I have access to, all of it kind of comes back to the long arm of Clyde Tombaugh.
That's funny. I feel like you and I are cousins, because I'm, a couple hundred feet or whatever from the telescope that he used to discover Pluto. And the Tombaugh presence here is so strong. And Clyde's kids, Al and Annette, still live in Las Cruces, and they still participate in events. Every year in February, we hold an I Heart Pluto festival celebrating Pluto and its discovery, and the Tombaugh family is still here. So I feel the same thing, that every day there's something I do with Clyde Tombaugh, it feels like.
Yeah.
And you mentioned,
if you're ever in if you're ever in Las Cruces and there's like a New Mexico State University outreach for astronomy, you might get to see some of the telescopes that he was a fan of building in his garage.
Yes, in fact we have one of those telescopes, the classic one he built out of farm parts, because he didn't have money, so he used, instead of ingenuity, he didn't let the lack of funding get in his way, and he used the base of a cream separator, a shaft from a grain elevator, a piece from a Buick automobile, and built this telescope, made drawings with it, sent them to professional observatories to see what they thought. And one of those places was Lowell. Ended up, because he sent that letter, he got a job here, and a year later he discovers Pluto.
Yeah.
And it's just a great story of persistence. If you love doing something, you can find a way to make it happen. And Clyde is a perfect example of that.
Sorry, go ahead.
No, I was just gonna say we're just about out of time here. We could do this all day because it's so much fun. But I wanted to also mention, you were mentioning some videos that you'll be creating. Check it out next week or so. We also have so many people taking great pictures. Bill Ferris, who has a long connection with Lowell Observatory. He and his wife Alice worked here for a long time. Bill is a master photographer, and so if you look at his Facebook page, he's got some really great images up there. And then, after this, you can experience it and watch it, but after this, there are going to be so many great images that astronomers and photographers have captured that you'll be able to remember this for a long time, even if you didn't get a picture. It's good, this kind of experience, you just enjoy it, and then you can always get a picture later. So
Yeah.
gosh, we're out of time. As this always happens, this has gone way too fast. But I'd like to thank you, Sean, for joining us. This has been spectacular to hear about you, my cousin in astronomy, and all the stuff you're doing at Sunspot. And I'd like to thank our other partners and team, Steve Placidus, who has provided us with spectacular view of the sun, Grand Canyon National Park, Grand Canyon Conservancy, the City of Flagstaff, and so many other partners, Planet Science, and also our behind the scenes crew, Heather Craig and Maddie Mooney. I'd like to thank some of our young viewers like Addie and Senna and June and others, so many kids that are around here that we've seen, and others around the area like Doug and Dorothy. So many friends, family, others that tune into such an event. It's a public event, it's a family event, something to share with everybody. And so we appreciate everybody joining this broadcast. And until next time, thanks for being part of this. And you can still enjoy some of the partial phase of the eclipse. So go outside and safely, as Sean said, safely view it with those glasses, or with the projection, or on the side of the building, or however you can see it. So thanks for joining us, and we'll see you soon.
Thank you so much, Kevin. Everybody out there, have a great day.